We're ready to solve equations here. So our standard, solve linear equations in one variable. And our goal here is to be able to solve these one-step equations using multiplication. So far we've looked at solving these equations with subtraction and then addition. And so now we're ready to look at these in terms of multiplication and then division. So when we talked about solving with addition and subtraction, we talked about using opposites. Well, when we talk about multiplication and division, we have to talk about this word called an inverse. So inverse numbers are numbers that multiply or divide to equal 1. So for example, 1/2 and 2, if you multiply them, half of 2 is 1. 1/10 and 10, when you multiply them, you get 1. And so essentially, whatever your number is here, you're going to make it into a fraction, and it will become the denominator, so that when you multiply them, you go ahead and get 1 as your answer. And so that's how you get an inverse. Inverse numbers are important to us in solving equations because they allow us to move numbers from one side of an equation to the other. So it's a very similar concept to opposites, but it's not quite the same. These are inverses, and this is how we're going to go ahead and work through these. So this part has not changed. We still have equations, and equations have an equal sign. And so when two things are equal, they are in complete balance, and we know we've talked about this, that our equal sign is kind of the middle of this balance, and so both of our pans of our balance here, our scale, have to be the exact same. And so we must use inverses to keep our equations balanced. So if I think about this, there is 1p here. So I've got this fraction that is basically 1/2, and then there's a p that's with it. But I want to get p so that it is all by itself. And so what I need to do here is I need to think about, hey, I can multiply both sides by 2. So I have kept everything in balance. Okay, I multiplied this side times 2, so I need to multiply this side times 2. And I've done that. And now what I notice is 2 times this 1/2, they're going to cancel. And so all that's left on the left side is p, and then I get 12 as my answer. And so that's how we're going to be using inverses here to multiply. So here's an example. You and 3 friends are having a pizza. You divide the pizza evenly amongst you. So there's 4 total people because it's you and 3 friends. You each get 2 pieces. How many pieces were in the whole pizza? So this situation can be represented by the following equation. We've got the total number of pieces right here. We don't know that. There were 4 people, so we divided that pizza evenly, and each person got 2 pieces. And so that's where the pieces of my equation come from. And now, I look at this number that we are dividing by, and I want to multiply to get my inverse. So I know that now 4 divided by 4 is going to give me 1, and x is all that's left on the left side. I have kept everything balanced because I multiplied this side by 4. Even though it ended up canceling, I still had to put that multiplication there for it to cancel. And I've kept it balanced because I also multiplied the other side by 4. And when I do that, I get 2 times 4, and that is 8. And this was pieces of pizza. Another example here. You have a box of chocolates that you decide to share with that special someone. You divide them evenly between the 2 of you. You each have 12 chocolates. How many chocolates were in the box? So now you've got the number of pieces of candy, which we don't know, divided by you and that special someone, so 2 of you, equals 12 pieces that each of you got. So again, I'm going to multiply both sides to keep everything balanced, and I chose to multiply by 2 because that's what I was dividing by, and so I know that these things will cancel to become a 1, and it leaves me with c, and c is going to equal 12 times 2, which is 24, and in this case we've got chocolates. An example here that is not kind of a story problem, so we've got g divided by 7 equals 7. So for this problem, I notice that my denominator here is 7. So I need to kind of undo that division, if you will. So I'm going to multiply both sides by 7. I see that these numbers will cancel. And when it says show your work, folks, this is what I'm talking about. You're going to write down the problem. You're going to write down what you're going to multiply on both sides. You're going to show me what cancels. You're going to write what is left, and then you can write that multiplication, and then you can put a box around your answer. So when it says show your work, here's what I'm looking for in its entirety. And one last example here. This time I've got W and it's being divided by a -3. So regardless of what that sign is here, I'm still looking at that number, and whatever I'm dividing by, that's what I'm going to end up multiplying by on both sides. So I know that my -3's will cancel. W is left. Now I have 12 times -3 is -36. And we've got our final answer. So we've got several examples there. Make sure that we're mindful of the signs of our numbers when we are multiplying and or dividing. And make sure that you're writing down your work, showing your work, so that you know what cancels, what does not cancel, and how they are inverses. And that should take care of business.